Hello, this is Mr. Collier, and today we're doing trigonometric functions in context. So let's take a look at a few graphs here, and we're going to first determine whether it's sine or cosine. So recall last time, let's look at the parent functions of sine x and cosine x. So sine x, it always goes to the origin because sine 0 equals 0, and for cosine x, we have it always starts at 1. Okay, so that's what you need to look for. If it goes to the origin, or if it's shifted up and it goes to the principal axis more specifically, then it should be sine. So we would use sine for this one because it doesn't start at its peak, at its maximum or its minimum. It starts in the middle at the principal axis. So this would be sine. Let's write it down first, the model. Sine bx plus c, and then we can figure out all the values of a, b, and c. So c is the principal axis, which is 1. So c equals 1, because that's the principal axis. The horizontal line in the middle is 1. The amplitude is the distance from the principal axis to the peak, and this is 1 here, and this is 2, so I guess that's 0.5. Okay, now be careful, because it could be negative, so let's look at the context. This is flipped over. Okay, normally sine goes up and then down. This is down, then up. It's reflected over the principal axis, so actually the a value is negative 0.5. And you could also do the a value equals max minus min divided by 2, right? And then change it to a positive or negative depending on what you need, right? So the maximum is 1.5 and the minimum is 0.5. Divided by 2, you do get 0.5, and you can see it's a reflection. So let's just do a equals negative 0.5. The b value is always equal to, and you have to remember this formula, 360 divided by the period. Okay, period. And the period in this case is, the length of a full cycle. So this is the length of a full cycle, right? And that looks like 120. Okay, that's 120. So that equals 3. So b equals 3. So you can say y equals negative 0.5 sine 3x plus 1. Okay, now, next one. This is also sine, and it's also flipped upside down, so the a value is negative because it's reflected over the principal axis, and it's negative 1 in this case. The distance from the principal axis to the minimum there is negative 1. B is always 360 divided by the period. In this case, the period is from here to here. Is a whole cycle, so that's 180. So b equals 2. C is the principal axis, which is y equals 2. So c equals 2. So y equals negative 1 sine bx plus c is the equation of that. Next one. Now this one does not start at the principal axis. It starts at its minimum value. So if it starts as minimum value or maximum, we're going to do cosine. So this is y equals a cosine bx plus c. And it's reflected again. So normally cosine starts at a maximum, so it's reflected. So a equals a negative number. And you can see here the amplitude is 4, so it's negative 4. Cosine. Now b equals always 360 divided by the period. Period in this case is this distance, so that's 360. So b is just 1. C is the principal axis, which is actually y equals 0, so that's 0. So the equation is simply negative 4 cosine x, right? It's like a 1x plus 0, so it's just negative 4 cosine x gives you that graph right there. Okay, next. We have a couple more questions. This one here, now is it going to be sine or cosine? Well, they give you sine in the question, which makes sense. It doesn't start as minimum or maximum, right? So P in this case is the principal axis. So the middle of the graph is y equals 10. So P equals 10. Now we got a negative Q there, and it is a reflection over the principal axis, so the negative is already built in. So Q is actually going to be a positive number. The amplitude is that distance, which is 6. Okay, so the equation, or let's get the R value now. R equals negative, R equals 360 always, divided by the period. Now the period here, we don't actually see the whole function, so but you can see half the period is 60, so the whole period is going to be 120. So R equals 3. So this equation is y equals 10 minus, what do we say Q was? 6. Yeah, and sine 3x. That will give you this equation right here. D equals a sine, let's just build it up, bx plus c. Okay, so let's find the amplitude. The amplitude is 2. Okay, it's not flipped over, so we'll just keep it as positive 2. B always equals 360 divided by the period. In this case, the whole cycle is finished at 8 here, so 360 divided by 8 is 45. Okay, and then C is the principal axis, C equals 0, so the distance here, the formula for the curve is 2 sine 45x. Okay, so that's the equation there. Actually, we should probably use t. D equals 2 sine 45t, because that's the variable given in the graph.